So basically, today's agenda is basically understanding Delta Lake. Okay, Delta Lake is a separate storage layer. Okay, so it's neither a file format nor a file system. It's a separate storage format, you can say. Okay, so why we are saying it's not a file format? Because it's not like CSV, Parquet, Avro, and all. So the data is basically stored as Parquet files only. On top of Parquet file, it creates a separate layer. Okay, so Delta Lake is basically a separate storage format which basically leverages Parquet file format only, and it stores the data in such a way that it creates a ACID interface on that. ACID means in RDBMS you remember, like ACID means atomicity, consistency, isolation, and durability. Means every other transaction should be ACID compliant, right? It should be atomic transaction. It should be isolation when it is happening. Another transaction should be able to modify this consistency, like one write operation should make your data mart from so your data like from one consistent state to another consistent state. And durability, like it's permanent, is that once the transaction happens it's permanent, right? So basically, till now, what we have seen in traditional big data projects or data lake projects, what happens? So we always create the data lake, which is uh, which is basically OLAP compliant. Okay, means online analytical processing. So all this BI reporting, all these things we generally do, or bulk insertion, bulk delete. Okay, those kind of operations generally we do on data lake. Okay, it's not like RDBMS. In RDBMS, we do operations like record level insert, update, delete, right? Record level insert, update, delete, and you can basically insert a single record. You can update a single record. It's like single record or multiple records, just like we do in normal RDBMS, right? So we don't have that kind of options on data lake. Okay, data lake is basically what you have seen in your project execution. You read data from all these different systems and write it to a S3 bucket. So in that case, we just say like, yeah, this S3 bucket is our data lake where our data is basically raw data is basically getting stored as it is, right? Our raw data is being stored there. So we are saying, yeah, this is our data lake which supports bulk, insert, update, delete, and all. So, but how to basically enable this ACID properties? Okay, so ACID properties means the same thing what I mentioned. Like I want to basically take a control of at a record level. Okay, that is not there in traditional data lake because it's whole bunch of Parquet files partitioned over certain attributes. So it's always bulk operation, isn't it? And and the same time, if you have, I'm not sure if you noticed that or not. So here there is no, it's always schema on read mechanism at work. You write some data in a basically directory, and suppose a data set having say 10 columns, having each and every column having certain data type. You keep on writing the data. Okay, so you worked on a project. Your job is to basically read the data and process it and write it there. So what you did, you keep on doing the same thing. Okay, you keep on doing the same thing. But what happens, like suppose a change request came in. Okay, so some request came in that you have to do some modification and all. So while doing that, you made a mistake, like you changed the data type of an existing column. Okay, earlier you had 10 columns. So one of the columns is now say changed from string to float or float to string, like that thing happened. Now while writing the data, it will not give you any problem. Okay, so you have you have your automated job running since last 2 years. Every day you are adding new partitions to that directory, and now basically what happens, like going forward, what you do, you now started adding new partitions as after the changes happened. And now what is happening after these changes happened, your different data set, like same 10 columns but one column has a different data type. Not just that, suppose you end up adding a new column to that, or you removed one column, anything you can do, you did a modification and you started persisting the data into the same directory. So what will happen, so in the write time it will not fail, but now in the read time it will fail. Okay, read time it will fail as in it will see like when you're reading the data by specifying the root directory, so it will say like schema violation happened. Like some partitions are having a schema this, and then and some partitions are having schema this. Okay, so whenever this is the case, like your entire data might got corrupted. You have to do manually check like till till which partition, till which date the data was of one format, and on which date onwards your data become corrupted, or your data become this your data became a different different format. Okay, a different schema. So all these things what you saw, all these things what you saw is all these things what you saw is so you saw like the data is of now different ones. You have to manually check like which partition, from which partition onwards you started seeing this difference, and you have to manually delete it and you have to correct it. Sometimes it's become very tedious, like it takes a lot of time to do all this. Okay, that is there. And now so that is one thing. That means schema enforcement is not there here. Okay, there is no schema enforcement. You can keep on writing any type of data, so the writing will be smooth, but while reading the data, you will not be able to read the data because the data is already corrupted. Some partitions are of one type and some other partitions are of different type. So that is also one of the problem with traditional data lake. And the third thing is basically related to the same only. Data mart versioning. Sorry, data lake versioning. Versioning means like every time you apply a write operation, maybe delete, update, or merge operation. So what happens like every time you apply some operation, so basically traditional RDBMS just maintain a version in the backend. Okay, so basically roll back your database from one consistent state to previous consistent state. So roll like there is no versioning available in data lake. Okay, so there is versioning as in like date wise the data is stored there in the bucket, but in the directory. But sometimes that can also be problematic, right? So so we are saying our data is available as date wise partition, but that is not the replacement of a version. Okay, so programmatically you cannot use that as the version column. So, but here using Delta Lake, so you will be having a version associated with every write operation. Every time you do a insert, update, or delete, so it basically adds a new version. Okay, so that what happens like if your data lake get corrupted in one, or basically you did some changes and you want to roll back, or you made some data mistake like some column is wrongly populated and all. So in that case, you can roll back your data lake from one format to one version to another version. That is called time travel in the Delta Lake. So Delta Lake manages all these things. Okay, it basically adds a asset nature, that is insert, update, delete at a record level control, and basically schema enforcement. So you can basically enforce the schema. So by default it enforces the schema. You put data mart is up, so your data lake is up having this many number of columns, and these are the different data types. The moment you try to write a separate partition or separate data or separate record which is of different schema, then it will fail immediately. Okay, it will not allow you to insert it. That is also there. And versioning is also there. Every time you read write, every time you apply any write operation, a new version get added to that. So that gives you an option to basically roll back or basically see the data lake at different versions. Okay, that is also there. So all these functionalities we are getting here in this particular Delta Lake. Okay, so people ask like, are you using Delta Lake in your project? So you can say like wherever you have, so you can see our staging there is a Delta Lake. Okay, so you can see like we are using Delta Lake because many companies have started using Delta Lake. It's really a good performance and all. So many projects you see like in real time now, people are using Delta Lake also. So let's see a couple of examples. Like first, what we can see. the schema enforcement thing, what I'm saying, no? So this is the thing, like once we create a Spark session object, then this is the Spark context object, then you read the application conf and secret conf. Then this is the directory I'm just mentioning. The df path is schema enforcement. Then first I'm writing the data. Okay, I'm writing some data here. So what I'm saying, I created a data frame set data equal to Spark context.parallel days. So I have two records. Okay, country, year, and temperature. Okay, I have two records. I just converted into data frame. Then I call show, and then what I'm doing, I'm just writing this data dot coalesce, then dot write format parquet, then dot mode. Then you are saying overwrite dot save this one. Okay, you are writing this particular data frame to this location called schema enforcement. Okay, you are writing that data as a parquet file. Okay, now basically you're trying to read this data. Okay, how to read the data? Same thing like spark session.read.parquet, specify the path, then call show function. Okay, that's how basically we do. So now can you basically execute this code, Varun? And just copy paste the access key secret key from any of the previous project.
I'm doing it.
Anyway, so that's fine. Let's just scroll up, see if 3 is there or not. Yeah, 3 is there, right? And in the application conf file also, you need to make change. In the application conf file, you have to specify your own S3 bucket.
Okay. Okay, I need to change the S3 bucket name.
Okay.
How should I change it?
There in EMR.
In EMR. No, only git pull, that's it. Only git
Okay,
pull.
only okay, only git.
Okay, now just execute that command, that first application. Yeah. Okay, so first we created a data frame having 3 columns, country, year, and temperature. Then we are showing it. Then we are writing this data as a Parquet file. Okay, so the data is written. So I'm writing data, then write completed. Once I write the data as a Parquet file, and again I'm reading the Parquet file, what I've just written now. Okay, so that's what I did in this particular section. Now what I'm doing, I'm just trying to append some data there. Okay, so what I'm doing, I'm just appending this data there. So I mentioned 2 steps. Okay, first I just created a fresh data, and then I'm appending it. Okay, so here what you see here intentionally, so I created a new data frame having exactly same fields, country that is Australia, year is basically now it's basically decimal, it's float. Earlier year was an integer 2011 26 here in line number 35 and 36, but now I just intentionally changed the schema. I made it like a decimal value. Okay, and temperature remain as it is, decimal. Okay, now I'm writing this data. Okay, new data frame dot coalesce one, a single partition I'm writing to the same directory. Okay, where the earlier data has been written. Can you again push this code and run it there? Now I just pull the outdated code. I want to run the same Python file in append mode. Yeah, just execute the same Spark submit command. Yeah. It should fail because what we have done here. So if you just see, It first created a new data frame. So you can see Australia 2019 0 and 30 is the temperature. Writing data, write completed. Okay, so earlier the data was having 3 columns: string, integer, and float. And now what you did, you added string, float, float. Okay, so the write was completed. The write was not giving any error. You can see write is completed. Now you are trying to read the data. Okay, now you're trying to read the data. So now it's failing. So what it is saying, task failed, compute this and all, query exception, Parquet column cannot be converted in file this, schema this, column year. Okay, so you can see it saying this particular year column having some problem, expected double, found int. Getting a point? So here only this problem happened. So earlier you had integer, but now you just write a data set, that is write another partition where year become float. Okay, so now basically same column is of having two different data types. Okay, write was smooth, no problem with write, but when you read the data, it's saying your data is already screwed up. Okay, it's already messed up with the schema part. Getting my point? So this is what the problem is. So in traditional data lake, if you just it's only write or write append job, you keep on appending the new partitions, but unknowingly you did a mistake and the entire data lake is corrupted now. You know, people who were consuming the data, the applications which were consuming the data, they won't be able to consume your data anymore. Okay, because the data is already corrupted. Okay, some partitions are of type are of certain schema, and some other partitions are of type different schema. Okay, so now basically these things are basically now basically what happened. So this kind of problem is very common in traditional data lake. Okay, so because all big data applications work in this manner, so they never check the schema while writing the data, but while reading the data, they check like all partitions are of similar type or not, otherwise it will fail. Okay, that is there. So this is basically what is called about the schema enforcement part. Okay, so your basically traditional data lake doesn't support schema enforcement, but we'll see like how it has been implemented here in Delta Lake. Okay, for Delta Lake, what we are doing, we are adding a couple of additional stuffs. Like you can see, like I'm adding this in here this AWS library as well as Delta Lake library. Okay, io.delta delta core to 11060. Okay, and couple of other options, retention duration check enabled, then log store class extensions, SQL extensions. Okay, here we'll be using delta related SQL as well, and then basically Spark Hadoop FS, then S3A, so the access key secret key also you have added, and post that what you did here, the same query I have just same code I have rewritten. Okay, same code I have just rewritten. So I'm just overriding the same schema. I'm saying exactly same data frame what I have created earlier. Okay, the temperature data, country, year, and temperature, and then data.print schema, data.show. Okay, and all this, and then what you're doing, you're basically calling that data.coalesce, then you are saving this. Okay, so here you can see format I'm mentioning delta. Earlier you are saying format was Parquet, but now I'm trying to store that data as a delta table. Okay, not just Parquet files. On top of Parquet file, it will add an extra layer that is called delta table. Okay, we are providing the format as delta dot mode override dot save, that particular path you are giving. After writing the data, you want to read and see the content. So now you won't be able to read it a normal Parquet file. You have to read it using the delta table syntax. Delta table dot for path. Then you are mentioning Spark comma. So this is the Spark session object, and then the path. Okay, you read this as a delta table, and then you are converting into Spark data frame, and then you are calling show. Okay, delta table dot 2df dot show. Okay, so if you just run this, so first it will try to create a delta table. Okay, it's created the data frame having 3 columns: country, year, and temperature. Okay, string, long, and double. Then you are basically creating a data frame and you are writing the data as a delta table, because you have given that data frame dot write dot format delta. Okay, and then you provided the location, then it should write the data as a delta table. Then you are saying write completed, and then you are reading the data again using delta table dot for path spark session comma, then you are mentioning the path. Okay, and then you are converting that to 2D, then you are calling show function. Okay, this is how you can see these things happen. But let's see what is the difference. Okay, so we didn't see like programmatically or output wise, we didn't see any difference. Let's see like how actually the data is stored. What's the difference in storage in our S3 bucket? You can see this is a schema enforcement. This is the directory it just created. So you can see what it is doing. Is this the path? Schema enforcement. There is background noise here. So okay, the path is basically schema enforcement delta, not schema enforcement. This one. Okay, schema enforcement delta. Yeah, now you can see first time you just write the data, it's created a Parquet file. Okay, as we were like discussing, it stores the data in Parquet format only. But along with that, so in normal Parquet and all, you saw it creates a success file underscore success. But now it's creating a directory called delta log. Okay, so in delta log, it created the first log file. Okay, now you can just quickly download this and see the content. So you can see along with what you call, along with the data, it created a extra log file. Okay, extra log file. So let's see how that log files look like. Okay, I'm just opening it in Notepad.
One second, Siddharth.
Mm-hmm. Okay, so what you can see, yeah. So you can see like along with the data, it created this log file. So it is saying at this particular timestamp, you did a write operation, mode is overwrite, there is no partition by column, and number of files is just one such partition you have just written. Okay, and all this information is just capturing. Number of output rows is basically two such record you have inserted, because we have two records, Brazil and India or something like that, Brazil or Australia, kind of like that. Okay, all this information along with that the metadata of that particular file. It's a Parquet file. Columns are of types name. You can see column are of type fields with name, country, and temperature, something like that. Okay, temperature, all this column information, and there all these things are stored there. Okay, now what we'll be doing, so this is how you can see it basically maintains the logs or the transaction log. It's like RDMS also maintains the transactional log. Similarly, Delta Lake also maintains the transactional log. Okay, so now what I'll be doing, I'll be appending some records. Okay, I'll just append this record. In this append, what I've done, I've again created a new data frame having only one record, Australia 2019-30. Okay, dot 2df country, year, and temperature. Then new data dot print schema. Then new data dot show. Okay, then basically new data dot write dot format mode save. Okay, like that the data has been stored there, stored in this particular directory. Okay, you have just written the data into this particular directory. So but it's a different schema. Okay, earlier it was string long and double, but now it's string double and double. You just change the schema. Okay, can you just push the changes and run it? Okay, you can see like we have added a new record, but its type is string double double. Okay, now it's trying to write the data to delta table, so it should fail. That's why only we are using this. That's why only we are using this delta table. So it failed, right? We saw like it's now failing. It's not allowing you to insert any record which of different format, right? So so what it is saying like writing data here, but writing not completed. So what it is saying, SQL analysis exception for failed to merge field year and year. Okay, failed to merge incompatible data types. Okay, long type and double type. Okay, that's one thing. Okay, now what you're saying like your data lake is safe from getting corrupted because of incompatible or different type of schema. Okay, so this is what we are discussing about schema enforcement. Okay, delta lake basically adds schema enforcement to your data lake. It never allow you to add any kind of junk data to your data lake. Okay, that is there. So that is there, and post that. Okay, that is there. So now let's go to the next example. So that is basically the schema enforcement part. Then the next thing is basically we can see like it also supports update. Okay, record level update. So what you can see here, I'm reading the same data. Okay, schema enforcement delta, and then what I'm doing, I'm reading this file as a delta table. Okay, delta df is equal to delta table dot for path session in that particular location where I have two records, right? India and Brazil, and their year and temperature. And I'm calling show. After that, I'm just updating. Okay, so you can say delta df dot update. Okay, so what's the general syntax of update? Update table name. So you update table name, set some value, where some condition. Means you're updating few records. Each record you want to update, so you have to provide a condition, right? So here you are saying update. First part is it's taking the condition country equal to Brazil. Okay, so you want to basically modify those records where country equal to Brazil. There may be a single record, there may be a multiple record. If there is, so it doesn't matter how many records are there, all records will be updated. So you're saying country equal to Brazil. So you can give multiple conditions also, say country equal to Brazil and year equal to something.
Yes, Siddharth.
Yeah,
Here we are updating the temperatures for all countries having called Brazil country.
Yeah, all records where country equal to Brazil. But for us, there is only single record. So that's why like single record will be updated. But the idea is that, okay, you are trying to update all records where country equal to Brazil. Okay, so you can give in nested conditions also like and or operator, all you can use. Okay, that also you have used in later examples. So your country equal to Brazil, and what attributes you want to change, that you have to pass it as a dictionary. Okay, you're saying I want to update the temperature as 24.0 tonight. Okay, so that's what you're doing. So you're saying update all these records where this condition satisfied, and update all these columns with this value. Okay, update the temperature with this value. Again, you have some another column to update. You can comma that column name, column value, like that. You can keep specifying multiple update values. Okay, like that. So now you are calling delta df dot to df dot show. Now can you run this code, please? So first we are reading the data from that delta table using that path. Delta table is only what you saw, like it's the same Parquet file along with that full bunch of transaction logs. Okay, so that's basically the way Delta Lake has been like what do you call has been started. So you can see it's reading the data: Brazil 2011, 22, India 26, 24, and you are now updating the records where temperature equal to. So you are updating temperature equal to 24, where country equal to Brazil. Now you can see Brazil is now changed. Okay, it's instead of 22, it become 24. Okay, like that. This is how basically update. So earlier in traditional data lake, you don't have any update option. You have to always delete it and add it again. There is no update operation. But now you can see you have this update operation also available to you. Let's go to our, so let's see like how, so this is the update is also another write operation. Like for every write operation, it will add a new log file. Okay, you can see a huge 000 end with 0, end with 1. Like this is a new file added. This is a new, what you call it, transaction log has been added. So I'm just opening it. Let's see what kind of log it just added. So you can see what it is saying. Operation is update. Okay, predicate. What's the condition you have given? Condition you have given country equal to Brazil. Okay, read version is 0, is blind, something like that. Number of files added is 2. Number of records updated is 1. Okay, 1 because there was one record having country equal to Brazil. All these transaction logs it's capturing here. Okay, so what it is saying, it's removing this path. Okay, and then adding this new path. Okay, so it creates multiple partitions because it can just simply delete the record and delete the partition. It has to keep because sometimes you may want to go back to some earlier version also. So for that, you have this option of, so all these files maintained there. Okay, so multiple partitions will be there, data duplicates will be there, but through this log, it manages the delta table. It's update operation. This is the condition and how many rows updated. All this information is captured here in the this part called delta rate only. Okay, in this particular delta table, these records are now with the updated state. Okay, this is how basically you can apply update operation. Okay, earlier update operation was not there, and now you are able to update it. That's two, again in at a single record or multiple record level also. Okay, so this is basically the update operation. Similarly, let's try with the delete operation also. So if you just go there, delete demo.py. So you saw like, yeah, sorry, what I was saying, like, yeah, you saw like in the previous example, you updated the record where Brazil was having 22 point something, but but now you modified it to 24. So that's why, like in this particular example, when you are reading the same delta table, you are reading the data that is Brazil 2011, 24.029, and India is this. So you are deleting the record where country equal to India, and then you are saying, so you deleted that record. After deleting, you are again reading the updated delta table, which is having only one record because you have deleted the India record, only one record, that is Brazil. Okay, that is how basically that is how you can do delete at record level also. Earlier, there was no such delete operations were there. Okay, in a traditional data lake, you cannot programmatically, you can't delete anything. You can go to the file system and you can basically remove few partitions, or manually you can go to S3 console and remove few direct few partitions. But basically what we do, we don't. But basically what we do, we don't have any control to do record level delete updates. So but now you can see we have record level delete updates. Okay, same thing you can see, like it would have like again created another log. Okay, you can see the second log. If you just open it, you will see it's showing some delete operation is done. Okay, this record has been deleted, that record has been removed, and all this kind of thing. Now, so this is basically you saw delete operations. Then another important thing is called merge operation. Okay, merge is very important. So earlier, how you are writing or appending data, you are basically calling the data frame dot write dot mode append, and then you are adding your data frame to that same parquet location, right? But now you can, instead of using that, you can use merge operation. Merge operation means it's offset operation, update and insert. So you can give a condition. If this condition satisfies, then remove this record. You can say also if this condition satisfies, not satisfied, just simply insert the record. Okay. So offset means like you are updating few records. Your basically pipeline is running in an incremental fashion. Every day your job is running and it's adding a whole bunch of new records to your data lake, as a whole bunch of new partitions, right? As a whole bunch of new partitions. Now what you are saying, like you have your data. Now what you're saying, you have your data available as a delta table. You can't just keep on appending or like overwriting as normal Parquet files. You have to use merge operation. Okay. So how you want to merge? You want to merge means two things. You are adding few records fresh, or you are basically updating few records. That's what you are trying to do. Okay. Here basically what we are doing, you are saying what we are saying. You are basically calling merge operation. First, let's create. So what I'm doing, I'm first creating a new delta table having the same data like Brazil, India, the same data I just created. Then I'm calling that show function. I'm showing it and then writing it as a delta table. It's a new delta table having this location called delta merge delta. Then this is basically I created a new delta table. Then I'm just merging. The second step I'll be merging. I'm creating a new data frame again. Okay, having Australia, India, and India. Earlier only Brazil and India. So now I'm saying I just want to merge this new data with the earlier delta table I've created. Okay, so for that, what you can see, delta merge df. Okay, delta merge df is basically the actual parent delta table. Okay, so this is the delta table through which I want to merge this new updated df. Okay, so that's what I'm saying. Dot alias, give the delta merge. Dot merge update data frame, give alias as update. Then you have to give condition. Okay, condition, you are giving two condition. We are saying country equal to, so delta merge means original delta table dot country equal to new data frame what you want to merge, that dot country, and similarly original delta table dot year equal to new data frame dot year. You are providing this join condition kind of, or merge condition you can say. Yeah, it's pretty much similar to your join condition you provided. Then you are saying when matched, when this particular thing matched means you can see where it will be matching. You can see India 26 is there, and here also India 26 is there. So this is a match. Okay, this merge condition will match because you're giving a condition on join and the country and year. So these two records will be matched. So you are saying When it is matched, temperature equal to update temperature. Okay, so that means this particular record is matched from the original data table and the new data frame. So you are saying like when it matched, just change the temperature part. Okay, earlier you can see 26 temperature was 24. Now you are saying update it to 25. And when not matched, then insert. Okay, so means when you are merging, there are two conditions: whether it will be matching. Okay, the merge condition, what you are saying, it will be matching, or sometimes you can say when there is no match. Okay, when no match, simply insert country equal to update country, year equal to update year, temperature equal to update temperature. Okay, means only this particular record match. So this condition just executed and the temperature just updated to 25. But for rest of the two records, Australia and India 2010, this record just got freshly entered and then not execute. Okay, so let's can you just push the code and execute this? Okay, so you can see like this is first time you're creating a data frame and you're writing it as a delta table. Okay, the write is completed. Now you can again go there and change the tape to merge. Means I could have like written multiple code, but I just tried to finish this in a single file. Okay, now it will trying to find out like which records are matching, and those matching records will be updated and non-matching records will be fresh inserted. Okay, we can go and see the location also. Delta merge delta. So first time we just written it, so oh, right is completed. No. So first time it's just written. Second time we're trying to merge it. We created a new data frame, Australia 2019. Why it's giving error? Shouldn't give any error. I think some version mismatch is happening, but it still should run. Okay, some version mismatch is happening with EML. That's fine. So now you can see the updated delta table is looking like this. Okay, India is now 26 is updated to 25. Earlier it was 24. and India 2010 is added. Australia 2019 is also added. So you can go there. It's a new thing has been added. So let's see how for merge how it basically does that. So you can see a couple of extra records has been added. So what it is saying, it's the operation is merge operation. Okay, so the predicate is country equal to country and year equal to year, and basically number of records, number of target rows deleted 0, number of target files added is basically 4, number of records, total number of records are 4, number of target rows inserted is 2 because 2 page records India 2010 and Australia 2019 has been added. Number of total output rows, source rows are 3, like the updated data frame are having 3 records. Like all this information it's capturing, so you can basically track that also. So that is there, and now okay, that is there, and now what we are doing, okay, this is basically the merge operation. You can merge records there, and on the same data frame, you have same delta table you are trying to no, it's in the schema enforcement delta. You are trying to see the versions. Okay, so this is called time travel, or basically versioning of the delta lake. So first you created a delta table dot path. From this particular path you are reading and creating a delta table. Then you are saying that delta table dot history dot order by version, then show. Okay, so now you can see like how these versions look like. Okay, so you can see it's providing all these informations along with the version also. You can see version 012. Okay, that schema enforcement delta we just applied first time we write the data in overwrite mode, then you update and delete. Okay, 3 operations. So you can see these versions are appearing here, and then you can basically pick a particular version and see the data also. Okay, so here what I'm doing, I'm just picking up only one version and see. Okay, so when you are doing the debug, you can go to different versions. Okay, you can see read.format delta option version as of 1. Okay, you saw 3 version 012, so you're trying to read the data with version 1. Okay, so you can also see that. So version 1 means basically we just applied the update. The version 2 we have just applied the delete. So by the version 1 we should get 2 records. Right, with updated India temperature was some 24 point something. What happened? No output, is it? Why is it like that? No output. Didn't I put any source statement there? Oh, sorry, my bad. Instead of this one, I made a wrong change. So you can see with that version, like after update version, so the India it was updated to 24, but rest of the records as it is. Similarly, you can read multiple versions. Okay, so these are a couple of examples in Delta Lake. Okay, just like we saw in batch mode. Similarly, you can try it in streaming mode also. While processing the data in a Spark stream, then there also you can make use of delta table. Okay, you can basically earlier you were saying like how to write it as a PySpark file. You can now write it as a delta table. Okay, so that shouldn't be any different, right? Because you saw in streaming also the same data frame syntax you were using, and now using delta table also you can write the data. Okay, there can be many different like scenarios where you can use. Okay, so you got a fair idea. Like in the when you are doing so the staging layer can be a delta table. Okay, you are trying to create a replication of the original data as it is. So in that case, you can think of using delta table. Right? That is there.
See that when we are using now delta table, then we no need to use Parquet or something.
Yeah, but it's not ideal for all scenario. Yeah, so since you saw like in the backend, it uses Parquet and the storage layer is basically delta table, but that doesn't mean like you should always use delta table. But it doesn't matter if it is required or not. But you saw like if you have this kind of scenario where you want to upsert the records or you want to insert, update, delete records at a record level, then you can think of using delta table. Not like everywhere earlier wherever you are using Parquet, you can just replace it with a delta table. That's not the case here. Only when it is required. Okay, for example, you are trying to create a real-time data lake. Okay, real-time data lake means say you are working for some e-commerce company. Okay, so you want to create a data lake which is still getting refreshed at real time. Every time a transaction or the sales initiated, so the same sales goes through multiple stages, right? You put a order, then the payment processed, then the seller just confirmed the delivery, and then he just dispatched. Then basically the what you call, then the courier service just in transit phase. Finally, you get the product. Then basically you don't like it. You just exchanged it or a deal or basically returned it. So means a same sales transaction can goes through multiple stages. So if you're creating a real-time data lake, how you are managing that? that real-time data lake, how it will be basically storing the data. If you just keep on ingesting the data every second, so the same sales data will be having multiple copies because it has multiple status, right? Started, then dispatched, then delivered, returned. The same transaction ID will be appearing multiple times. Instead, what you can do, you can think of using a delta table if you want to store only a single version and the updated version of the same sales record. So you can think of using a delta table there. You can basically use the right merge logic to update your delta table on a real time. Okay, so that can be one proper use case. Okay, but if you're doing simply insert, update, delete, like when you're in a typical data mart project, the first part is source to staging. The staging should be there in as a Parquet file. Don't replace it with delta table. Okay, all these things. Okay, and you see like delta table operations are also little slow in comparison to normal write as CSV or Parquet. It's taking little time, right? So that's also one of the reason, because it just stores the data. Along with that, it just creates the logs also. Okay, transaction log JSON file, right? All these things are there. That's the whole reason because of which so these are the kind of use cases where you can use delta table when you want to create a exact same replication of a production database in S3 or HDFS. You can think of using this part you can think of using delta lake. Okay, so that's all about your delta lake. Any other queries on this?
No,
I have a
Siddharth.
question. This is insert update or merge operations that we are doing using Delta Lake. Can we do the same thing using a normal data frame? I mean, in terms of say when we talk about SCD1 or SCD2, how do we generally think about it implementing in a normal data frames, not using the Delta Lake? Is it
Without
possible?
using delta lake, you cannot achieve the same feature what we just achieved it, because normal data frame doesn't do all this. You can do that, but it will be very lengthy process. What we did, say update a record, that also you can do that. You can read the entire data frame, then basically apply with column function or select function to apply the transformation and write the data again back. It's a huge process, isn't it? Like your data is say it's running from last 2 years or 3 years or 10 years. You see the data volume is in petabyte scale. So update record means what? Like you read the entire data, apply a with column function to modify it, and write it back again. So here in delta table, it manages the transaction log. So that's why it's not doing all records in read and update and delete, insert again. Rather, it's somehow managing. They have created a separate file format and storage format through which they're managing. But if we will be doing it through data frame, this is the process. Read the entire data frame, then update it using with column function, then overwrite it back. And if you make some mistake, then the entire data got lost. It's risky, right? Means overwriting the entire data is basically it's risky. That's there.
Yeah.
And same thing for delete and merge also. You can achieve it, but it's risky. And it's also time consuming. Okay. Delta table, if it is taking 10 seconds, there it will be taking say maybe 2 hours, 3 hours, because you're doing it on the entire data set. That is one thing. And coming to SCD1 and SCD2, that you can achieve in every, whatever the format you are using, you can achieve that, isn't it? So you are trying to implement SCD2, you can do that also. Means normal data frame also you can use. Suppose you have some customer data, so new records are coming, you create 2 data frame and check like which are overlapping record. Then you basically modify the existing records with these active false and from date to date and all these things you update, and in the fresh records you simply append or union and then write it back. Okay, that is also full refresh in case of data frame. Okay, but you can basically manage that, but this is possible. But in case of delta lake, you can pretty much do that. It's easy in delta table. Just create 3 more columns, say from date to date and is active, and then through merge operation you do that. You in the new data frame, you saw like the same customer ID is reappearing. Then you first in the matching, in the join condition, you provide that particular condition, customer ID is matching or not. Okay, then in the when matched condition, you update the records. When not matched case, simply insert the record. Isn't it?
Yeah.
So in those way, you can basically manage that. Any other queries? So you saw like in this particular delta lake, every time you are applying an insert, update, delete, so it's a lot of transaction logs are getting created. So what happened? We intermittently execute the vacuum command. Okay, delta table has a vacuum function also. If you call that, it will merge them together and it will just avoid all this. It will basically consolidate the data. Now what is happening now? Every time you are applying some write operation, insert, update, or delete, it basically adds. It cannot delete any record from the Parquet. It just it just stores all these records. Okay, all these records along with the versions. But once you call vacuum command, it will merge them together. So now all transaction logs has been removed. Okay, later you can again start applying new record insertion or delete or this thing. So this will be comparatively faster because you don't have many logs. Okay, many transaction logs. You have only one transaction, one final transaction log. From that again it will be restarted. Okay, like that. In pretty much all these MPP databases, you have seen that vacuum command is there. Okay, because they use some sort key and all. So when data is basically getting inserted in bits and pieces, so the sorting becomes like improper. Like sorting doesn't work improperly. So to get rid of that, we sometimes execute vacuum command in Redshift also. A similar option available here also. Okay, you can merge all these transaction logs as a single log, and then that will basically make your delta table a little faster. Okay, these are a couple of points. Okay, so we'll again connect, I think, Friday. So Rama, your batch, I'll just let you know the project part. And in the other batch, Vinay and all, your project part is over. I'll just, in the next session, I'll show you like how to use the state functions to automate it. Right, that's the thing, right?
Yeah.
Yeah, so for Rama and Ankun, I'll just update you when the project will be started. Yeah, I just still didn't get a chance to update the